All right, so we are here today. I want to remind you that there is a Delta Math that is due today. You need to have it completed before tomorrow because it is a review of completing the square. And tomorrow, in what we are doing, we are completing the square, and I'm not teaching you how to complete the square because that is an Algebra 2 skill. So you need to come in knowing how to do that. All right? And you will have a quiz tomorrow on 6-3. All right, so let's look at what we're doing today. So going on page 113 when we're done, we're going to start above where the notes actually start so we can get some info here. Okay, so we're drawing a triangle in the coordinate plane. On this last test, when you had to do that, some of you, the way you were drawing your triangles and where you had your vertices, I don't know where you've been because I've been drawing them in the exact same spot every time. And the whole idea is that this is theta right here. This is R, this is X, this is Y, right? So this is not, we're not thinking unit circle values, we're just thinking in general. So R is not 1. Gabby, shut your computer, please. And so that means that we know, well, first of all, something we've known for a long, long time and how this stuff relates is we know that x squared plus y squared equals r squared. Right? We also know that cosine theta, based on that triangle, is what over what? Specifically from this, it is x over r. There we go. And then sine theta would be what? Y over r. And tangent theta, y over x. Okay. So what we're doing today is we're going to be converting between polar and rectangular coordinates. Okay. And so it says, given point P with polar coordinates r theta, the corresponding rectangular coordinates x, y are given by this. So I need to take what I have up here, solve for x, solve for y. So I can easily solve for x from here. So if I just multiply both sides by r, I'm going to get x equals r cosine theta. And if I multiply both sides by r here, I'll get y equals r sine theta, which we've seen that before in some other stuff that we've done. Plus, if you're in AP Physics, that's your mg cosine theta, mg sine theta, right? And this is going to go right here. So x equals r cosine theta, and y equals r sine theta. So cosine's still hanging out with x, sine's still hanging out with y, like it always will. So we're going to convert. On the notes, we're going to plot these points. When you actually do it, I'm not going to make you plot the points. I just want you to see that regardless of what form you have it in, we're actually plotting it in the exact same spot. So let's, okay, turn that off, whatever that is. This is in the form of r theta right now. So let's go plot that point. It's at 2 5 pi thirds. So 2, go around to 5 pi thirds, I'm right here, and that's number 1. Okay. So we at least know something, even if we didn't plot this, and we think about where it is, we can think, okay, that's going to end up in the 4th quadrant. That's helpful, because then when we convert, we can make sure that whatever our point is will land in the 4th quadrant, right? And that way we'll know maybe if we mess up on our signs or not. Okay, so back up here, I've got that x equals r, which is 2, times the cosine of theta, which is 5 pi thirds. So that equals 2 times, all right, what's the cosine of pi thirds? 1/2. 5 pi thirds is in which quadrant? The 4th, and so in the 4th, cosine is what? Positive. So this is 1/2, and that just gives me 1. Then I do y. Y is equal to r, which is 2, times the sine of 5 pi thirds. So what's the sign of pi thirds? Square root of 3 over 2, and in the fourth quadrant, sign is what? Negative, so it's going to be negative square root of 3 over 2, which in the end gives me a negative square root of 3. So my r theta point is 2 5 pi thirds. My xy point is 1 negative square root of 3. So I'm feeling okay about this because that would land me in the fourth quadrant, right? That's at least something. Then we're going to plot it. And like I said, I'm not going to make you do these, so you're not really going to necessarily need to know the decimals. I'm just going to give them to you so we can plot them. And this square root of 3 is about 1.7. So I'm going to go to the right one and down about 1.7, so I end up kind of right there. But my point's really big, so this is number 1. And then you can look at the two graphs, and if we were able to put them on top of each other, the points should be in the exact same spot, right? One's a little bit easier to get more exact than the other, though, right? Because we're estimating on the rectangular one. Everybody good with that? Okay. All right, so let's look at number 2. Again, this is r theta. So x is equal to negative 6 times the cosine of 3 pi fourths. I just realized I forgot to plot it, so let's go back and plot it. So we're at negative 6 3 pi fourths. So I go to 3 pi fourths, what quadrant is 3 pi fourths in? Second. And then it's negative 6, so I have to pass through, and I end up right there. So that's 0.2. Right? Okay, so we can go back over here. All right, so then I get negative 6. What's the cosine of pi fourths? Square root of 2 over 2. 3 pi fourths is in which quadrant? The second, and the second cosine is negative. So that's negative square root of 2 over 2, which would end up giving me 3 square root of 2. Then y is equal to negative 6 times the sine of 3 pi fourths. So I know that the sine of pi fourths is the same as the cosine of pi fourths, so it's still square root of 2 over 2. And in the second quadrant, what's true about sine? It's positive, so square root of 2 over 2. So that gives me negative 3 square roots of 2 in the end. So then I take my x and my y coordinate and make it an ordered pair. And I can see that I was once again in the fourth quadrant. This once again would get me into the fourth quadrant. All right, so let's plot that. Let's see what 3 square roots of 2 is. It's about 4.24, so about 4 1/4. So I'd go to the right about 4 1/4 and go down about 4 1/4. It's right about there. And this is 0.2. You can see they're pretty much in the same spot. Okay, questions? All right, you do number 3 on your own. Alrighty, what questions do you have? Anything? We're good? All right. And let's flip it over. Now, the things that we wrote on the front but didn't use, well, the first one was x squared plus y squared equals r squared, right? And then we also wrote that tangent theta equals y over x. Okay? So we're going to have to go the other way. Given the point P with these rectangular coordinates, corresponding polar coordinates of r theta are given by blank. So I need to solve for r and I need to solve for theta. Here, if I solve for r, I'm going to take the square root of both sides. So r is equal to the square root of x squared plus y squared. Looks like I forgot my plus or minus, right? But really, we can just make the radius always be positive and not deal with the negative ones, and it all works out just fine, okay? Then theta, I would just take the tangent inverse. So theta would be the tangent inverse of y over x. So this goes in right here, square root of x squared plus y squared. This goes in right here, tangent inverse of y over x. Okay. What questions you got at this point? We good? All right, so let's plot this first point. 2 square roots of 3. So that's my rectangular xy. So this is x, well, this is xy, and I need to go ahead and plot that. So I'm going to go to, let's see, 2 square roots of 3. That's about 3.46, about 3.5. So I'm going to go to the right 2 and up about 3.5, and my point's about right there. That's number 5. All right, so I need r, right, for my x and y. So r is equal to the square root of 2 squared plus 2 square roots of 3 squared. What's 2 squared? 4. What's 2 square roots of 3 squared? How do you square that? That's 12. So that's the square root of 16, which is 4. Then I need theta. Theta is the tangent inverse of 2 square roots of 3 over 2. These can just cancel out, so I really just have the tangent inverse of the square root of 3, which is what? Pi thirds. Is there more than one quadrant where tangent is positive? Yes, so we have to take our quadrants into consideration here. Just by looking at this, whether I plot it or not, that's positive, positive. I know I'm in quadrant 1, right? So I'm in quadrant 1, which means I want the quadrant 1 angle, which is what I got, so I'm good there. And then so my point is 4 pi thirds. So if we go plot that on our polar, I'm going to go to 4, and then pi thirds, I'm right here. Looks like it's in the same spot, right? Oh, I don't think it is. Y'all let me plot that point wrong, and nobody said anything. Nobody wanted to fix me? Thanks a lot. Y'all back there making fun of me because I was wrong, and then, yeah, like, you just what? Oh, we've got to say it louder. Hey, dummy, back up, okay? Because I said it's like, what, 3 1/4? And I went to 2 1/4, and y'all just sat back there and laughed at me like I'm an idiot, and instead of trying to help me out. Thanks a lot. All right, so I'm going to go to the right 2 and up 3 1/4. I'm going to really do 3 1/4 this time. No. If y'all hadn't figured out by now that I'm not always right, I don't know where you've been with that either. Okay. And I also am not, if I really was right, I would not make you feel stupid. Like, how dare you question me? No, please question me. You should always question everything. That's something you need to learn as a human being. Question things, absolutely. All right. Now it looks better, right? That's how I knew I was wrong, and I was like, wait, something's wrong. Okay, we good? Okay, let's look at number 6. See if I can plot this one correctly. We have 3 square roots of 2 over 2. So that is 3 square root of 2 over 2. That's about 2.12, so it's just a little bit more than 2. So I'm going to go to the right a little bit more than 2 and go down a little bit more than 2. Oh, and if my pen would cooperate, right about there. That looks good enough. And that's number 6. Okay. All right. And so let's just go ahead and, I mean, we plotted it, we can see it, but even if we didn't, what quadrant are we in? 4. Okay, so I'm in quadrant 4. I need to take that into account in the end. So I start with R. R is equal to the square root of 3 square root of 2 over 2 squared plus negative 3 square root of 2 over 2 squared. Okay? Don't make it crazy hard just because there's fractions and square roots and you're squaring it. We can take this a piece at a time. If I square the denominator, I get 4, right? If I square the numerator, what do I get? 18. So I get 18/4 plus 18/4. I know some of you could have skipped that step. That's fine. So that gives me the square root of 9/2 plus 9/2. What's 9/2 plus 9/2? 18/2, which is 9. You have half of it and half of it, put it together, we get 9. We get 3. Okay? So you don't have to step it through that many steps. I mean, some of you probably could have skipped some of those, but whatever, just it's fine if you need to step your way through it and don't make up math. All right, so then theta is equal to the tangent inverse of negative 3 square root of 2 over 2 over 3 square root of 2 over 2. And we don't need to make that crazy hard either. I don't need to keep, change, flip, or do any of that mess. What does that reduce to? Negative 1. You got the same thing in the numerator and denominator, so I'm doing the tangent inverse of negative 1. Okay? What is the tangent inverse of 1? Pi-4. What quadrant do I want to be in? 4th. What's my 4th quadrant pi-4 angle? 7 pi-4. So that's the angle that I want. Okay? Does that make sense? So then my point is at 3, 7 pi-4. Then, of course, there's other ordered pairs that would get me to that same point, right? Like even if I had a negative rate, we don't have to worry about any of that, but it's not like the only point, but that is a point. It's the easiest one to come up with. So then we plot this. 3, 7 pi-4 is about right there. And hopefully this time they actually match better than they did last time. Looks like it. All right, we good? Yes? Okay. All righty. Let's see. I'm going to help you plot number 7, and then I'm going to have you do number 7. So I'll just, because I know you probably, I doubt you just know what that decimal is. Square root of 3 by 2. It's about 0.866, so a little less than 1. So we're going to plot this. I'm going to go like to negative about 0.75-ish, negative 1/2. It's kind of there. That's good enough. That's where my pen decided it wanted it to be. So. Okay. All right. You do the rest. So when you're finished, check yourself with me. I want to say overall I'm very proud of the great majority of you because I wrote parts of this up here and I half expected to turn around and see everybody, not everybody, but a lot of people staring at me waiting for me to do all the fractions, but that wasn't the case. You had your little heads down, you were doing your fractions, and that's the only way you're going to get them figured out, right? And now that we've been using fractions more and more and more and more, and those of you that aren't just ignoring them and you're embracing them, it's getting easier, right? It's not as scary as it was maybe for some of you. We've got to be able to handle them. All right. Any questions about what I did or where something came from or anything? All good. You know what that is. All right, then we're good. I don't think we need to do number 8, so you can go ahead and tape this in. Remember your assignments in Delta Math, but you also have that other Delta Math you got to do too.